Microsoft has dramatically reduced the barrier for integrating advanced analytics into your application across all three of those areas. So by providing highly engineered, highly tested, highly performant and scalable models, it no longer requires the same kind of domain or the same kind of machine learning expertise that it may have historically in crafting custom machine learning models.
So first off, I just wanted to keep in perspective where machine learning fits in the whole Cortana Intelligence Suite. Because one of the things that you'll see is how much each of these individual products fit together to make a platform that really uniquely enables advanced analytics applications. You'll see all of these different things fit in different places, but together they support a complete end-to-end data flow to have all of your ETL, all of your ingestion, all of your advanced analytics in a single cohesive place where they can be monitored and built as a whole all the way through to being deployed to your end user population.
My name is Jamie Olson. So at Microsoft, I am an analytics solution architect. So what I do on a day-to-day basis is I talk with partners and customers about the solutions that they're trying to solve and identify the ways in which we can leverage all of the different Azure products and combine them in a end-to-end way so that we can manage the entire solution all the way from, so typically we're talking about data applications and analytics applications, so all the way from the ingestion of the raw data, so bringing the raw data into the cloud, all the way through to serving the product, the analytics product, whether that's a visualization or a prediction, out to the end user. So now I'm going to go through some of the features of the Machine Learning Studio, which is the Microsoft development environment for building advanced analytics models and making predictions.
So I'm just going to talk a little bit about the machine learning here, and then we'll go pretty quickly into some demos. So the idea here is to leverage machine learning to get as much data as possible out, or as much value as possible out of the data. And so Microsoft is not a newcomer to machine learning. The machine learning product in Azure has been around for just a couple of years, but Microsoft has been deeply involved in machine learning research and a deep user and consumer of machine learning internally for the better part of the last 20, 30 years. So when you see some of these things coming into the marketplace, they're not new things. These are highly engineered systems that have had thousands of users inside Microsoft against terabytes and petabytes of data over the last several decades. So these are not new things. These are highly engineered, highly tested things, both in the advanced analytics and in the big data spaces. So what makes Microsoft different? There hasn't really been a whole lot of change in machine learning as it's used in the business world in quite some time. So it's still expensive and difficult and time-consuming to get all the way from data preparation, modeling with difficult to find and expensive data scientists, moving those models and operationalizing them, and then re-implementing any data transformation that they're doing into a production application. This has been, and for a large part continues to be, a really difficult problem for organizations. And so this is the problem that Azure Machine Learning is working to solve. By taking all of these different components and assembling them together in this single solution suite, it allows you to tremendously reduce the time and the effort involved, not just in building out a predictive model, but in getting to the point where the predictive model is impacting the business and getting those predictive results out to your user population. So this is really the differentiator, is getting the modeling output deployed and accessible to your business users or to your consumers. So what Azure Machine Learning does, the way that Azure Machine Learning enables all of this is by taking a general platform for machine learning and deploying it as a service, and which allows the predictive models that your data scientists build to be deployed and integrated into any application. So we'll show some ways in which Azure Machine Learning can be easily and directly integrated into some of the other Azure components, but it's not limited to that. These are generic RESTful APIs that any application can leverage, and we'll show a couple of different APIs, client APIs, specifically in Python, and so we'll show them from the perspective of the data scientist, but also keep in mind the application programmer can also take these APIs that are being deployed and integrate them with whatever platform they want, whether that's a JavaScript web app or a .NET app or a Python web server. So we'll talk specifically about how this integration happens with the Azure products, but it's not limited to that. This is just a general API that's enabling any application to consume the predictive modeling that your data scientists are building. So Azure Machine Learning consists of a number of different things, but one of them is the Machine Learning Studio, which is a platform for data scientists and regular developers to build and deploy predictive models. We'll talk about some of the other components of Azure Machine Learning as well. But in this case, this is a drag and drop user interface that allows experts and non-experts alike to build real world predictive models and get them deployed into production. So if we take a data set here, like adult income in the United States, we can pull that out, choose based on either some knowledge of this domain or some methodological preference. We can choose whichever kind of statistical or machine learning model we want. We can then specify that this model is going to be trained on this data set. And you can see it's telling us that we need to do something here. And so all we need to do now is choose the thing that we want to predict. So in this case, what we want to do is we want to predict income. And that's the only thing that we're looking to predict here. And now, let's say we want to evaluate this model. Oops. Now, all that we need to do for this to be executed is to hit the run button and wait a little bit. Oops. So one of the things that you noted as I went through this process is there are a number of different machine learning and statistical models that you can choose from. And these are models that are highly engineered, highly tested, highly performant, both on the training and the deployment side. So these are models that have been used internally by Microsoft across a wide variety of teams in real-world production use cases. Oops. So as this runs, you can see for these models, these are internal Microsoft engineered products, but they're highly configurable. So the internals of these models are exposed to your data scientists to configure in whatever way they see fit for the scenario that they're targeting. And once this model has been estimated, it is a simple two-click process to take a model that's built in this way and turn it into these web services so that they can be integrated into your production operationalized workflows. So now that this has been executed, we can take a look, see how it's doing, get some high-level information about the model and how well it's estimating our data. And then immediately set this up as a predictive web service, which is going to analyze the workflow from the input data set to the predictive model and identify the key stages that need to be executed in a production predictive environment. And it's going to transform that experiment into a prediction experiment. And so you see here there are a couple of new things that have been introduced, a web service input and a web service output. And so these are the data that is expected to be provided through the web, the RESTful API, and the data that's going to be returned from that RESTful API. And after I run this again to ensure that the automatic transformation in fact identified all of the necessary requirements, the only other thing that I need to do is click Set up a predictive web service, and then I have a REST API that I can integrate with Azure Data Factory or with any other application that I need to build. So what I have here is a scalable, performant web API that will take new data and return a prediction on what in this case happens to be income, but can be absolutely any predictive scenario that you have where your predictive output can provide value to the business or to your end consumers. So there are two different flavors of API that are provided, request response and a batch. These have slightly different performance as well as pricing configuration, slightly different performance and pricing, so they're useful in slightly different scenarios. So you can tailor the way that you're using these services to meet the needs of your application. Typically, this request response is designed to have low latency, but has less throughput than the batch execution. But it can depend a little bit on what you're actually doing inside these experiments. So this is the core idea of Azure Machine Learning. You saw how fast that was. And these models that are built in this way, you don't need to be a data scientist, but if you are, you can leverage the advanced configuration of these individual models and all of the different pre-processing that you might be doing on the database layer or in custom transformations to really tune and create the best model that you possibly can. So let's go back here and take a look. Oops. Let's take a look at some of these other modules. So in this case, I happen to use a preloaded data set that's provided as a sample. But there are a variety of different data sources that you can use. So you can import data from Azure Storage, from Azure SQL, SQL Server, either in Azure in VMs or on premises. You can provide Hive queries to data that's stored inside an HDInsight cluster. So there's a lot of different ways that you can pull this kind of data into a predictive model, as well as ways in which you can set up your experiment on the output side to put these predictions. So in this case, the way that we set up this web API was to receive the data directly as a parameter to the API call and return the predicted values back through the web API call. But you can also configure your web services to load and write the outputs directly into a SQL data set. So you can integrate this directly into an in-database pipeline without having to move the data out through the web API and without having to serialize the data in Azure Storage or anywhere else. And that's the export data, which has similar configurations to the data import. In addition to this model, the actual predictive modeling, typically your data won't be pre-cleaned and pre-processed like that. So there's a variety of additional data transformations that you can do, whether that's filtering data to remove bad data, splitting the data into train and test sets, doing data transformation to create new features from pre-existing variables, or other kinds of sampling to oversample infrequently observed classes. So if you've got a rare event like fraud, you may need to or want to oversample that to get a better predictive model. As well as a whole variety here of different classification and regression and anomaly detection algorithms. So you won't find everything here. You won't find the kitchen sink in here, but you'll find something to meet every core scenario. So we have simple numerical output regression. We have single class and multi-class classification algorithms. We have simple, explainable, human interpretable models in scenarios where that's important. And we also have things that are more black box models but might get higher predictive accuracy, like boosted random forest models. So there's a lot of different highly engineered, configurable, flexible models here. And if you need to move beyond what's available here, you'll also note that there are custom R and Python modules. And so we'll talk a little bit more about that in the next section. But in addition to these predefined drag and drop modules, you can take arbitrary R and Python code and insert it into this pipeline wherever you want it to be, including using any additional R packages or Python libraries that you want just by uploading them to this service. So one of the challenges that people face is productionalizing some of these Python and R modules, and Azure ML can make that dramatically simpler. So one of the things that you'll see on the side here is a couple of categories that go beyond traditional simple prediction and predictive models around predicting fraud or predicting income or predicting any kind of thing like that. But you'll see we have OpenCV modules here, which also allow you to, inside Azure ML, do image classification and other predictive tasks around image data, as well as some transformations here. There's a category here called Learning with Counts, which is designed around text data, but can be used for a variety of different scenarios in situations where you have extremely high dimensional data, where you want to reduce where you have counts, but you need to scale them to very high dimensional data. I'm not sure how else to say that, so the pre-built modules go beyond the simple, predict a number or predict a class scenario to include a broad variety of different scenarios that you might be looking to do modeling around. So in addition to building your model entirely from scratch, there are also features in Azure ML in the Machine Learning Studio that support sharing of some of these scenarios. So you'll notice once I created this model in the training experiment here, there's another button here that I didn't talk about, which is Publish to Gallery. And the Azure ML Gallery has a variety of different categories. So we were working there in experiments, which are predictive scenarios around taking an input data and turning it in and creating a specific kind of predictive model around a specific variable. And so these experiments can be published and shared across an organization or publicly, so that all of the different people in your organization who are working around predictive modeling can share the work that they're doing and share the solutions that they come up with in these different areas, so that they can be leveraged and reused across different specific predictive use cases. So you'll see there are a lot of different scenarios here. These go beyond the pure built-in modules to include a variety of scenarios with complicated R and Python code, as well as vision and other scenarios. So, one place to start with if you're new to predictive modeling and you're new to the Machine Learning Studio is to take a look at some of these. One of the things that I wanted to do is to take a look at the specific predictive model that we were using in this connected cars scenario. So here we saw a bunch of different times here, or a bunch of different things here, but one of them I can't find the thing. So one of them is predictions about cars that are likely to require maintenance at a short time into the future. And in the data factory that Vivek was showing earlier, you could see specifically inside that pipeline the specific activities in this pipeline where the machine learning predictions were being augmented, were being added to the raw data. So in this case, we have a recall model and a maintenance model. And if we hop over here into the Connected Cars workspace, we can start to look at we can start to look at the actual experiment that was deployed in the connected cars scenario. And it doesn't actually turn out to be a whole lot more complicated than what the experiment that I was just showing you. So you can see here, because this is now a model that we've put into a production environment, we've done the things that we should, like annotate some of these different activities with comments to describe what's going on. So we have our raw data coming in, which is split into data sets for the maintenance prediction and with the recall prediction. So we have the data sets without any recall scenarios that we use to build our maintenance prediction model, and our data set without the maintenance records to build our recall prediction model. We use project columns here to remove some irrelevant data so that we're not using fields like ID or maybe certain timestamp variables to try to build our predictions so that we're not getting erroneous predictions. And here, you can see how we're actually doing it. And here we're using a slightly different methodology. We're using an anomaly detection to do the predictions here, rather than a traditional random forest model. But we get the same basic structure to our experiment, where here we have two different scenarios. We have a maintenance predictive model and we have a recall predictive model. And we're combining a single experiment with both of those scenarios so that we can call a single predictive experiment and augment it with both predictions around recalls and predictions around maintenance. So there's a lot of flexibility in terms of what you put into one of these experiments. And so then the last thing that I wanted to do today is to just show you a little bit more of what's out there in the Azure Machine Learning gallery here. Because in addition to these experiments, there are also solution templates that are one-click deploy end-to-end solutions, complete with data generators. And so one of these happens to be exactly the connected cars scenario that we've been showing you. So this is literally a one-click deployment into Azure that will go into your Azure subscription and create all of the infrastructure needed to build this entire end-to-end pipeline, including the Azure Data Factory, including the SQL databases, including the storage accounts and the machine learning experiments, so that you can start to see how you might build and transform some of these pre-existing templates into your own solutions.
I think the most important thing to keep in mind after the talks today is how all of these different things fit together. So we're talking not just about individual products. We're not just talking about the Machine Learning Studio. We're not just talking about Azure Data Factory. We're talking about a suite of intelligence or a suite of products around advanced analytics. And where the real power comes in into this suite is how all of these can be combined to rapidly build out advanced analytics pipelines. So it's not just an old-fashioned ETL pipeline. It's might be a hybrid pipeline that combines on-premise data with cloud data, with Hadoop, with data warehouse operations, with machine learning. But all of these different things can be combined into a single application workflow using the Cortana Intelligence Suite products.